Hi everyone, today I want to start chapter 5, which is about programming counter or software counter instruction. Okay, let's first start with talking about hardware counters. We have two different types of hardware counters, mechanical ones and electronic counters. Mechanical counter uses shaft rotations to increment or decrement the numerical values. On the other hand, we have electronic counters in which their LCD can be programmed to count up, down, or both based on your input pulse transitions. However, hardware counter operation is not the goal of this chapter. So we are going to focus on software counters, but before starting software counter, I would like to show you a counting application. Here, this is our counting application. In this counting application, we are using an electronic counter to count the number of bottles that we do have on the conveyor. So here you can see that we are using a sensor. The sensor is photoelectric sensor, and you should be able to tell me what type of photoelectric sensor we are using here. Obviously, that's a transmitted beam with two housing on both sides of the object. So the sensor is being used to monitor the presence and absence of the object on the conveyor. Now, when the beam of light is blocked by the object, the output logic circuit of sensor will send 0 to the counter, which you can see that here. So this 0 means that the object is blocking the beam of light. And otherwise, it will send 1 to your counter. So if the output of the sensor is equal to 1 here, it means that we don't have an object in front of the sensor. Now your counter is programmed in a way that it can detect all transition from 0 to 1. For every transition, the counter value will be incremented by 1. Okay, so now let's go to software counters. I want to be general at the beginning. So let's focus what are different type of counter that we might see in different type of PLCs. Different type of counters are like this. We might see up counter, we might see down counter, we might see a high speed counter, or up down counter. Now remember that the up and down counter are common among different type of PLC. So no matter what is the brand, you will see up down counter. In some of them, you do have the up down counter as one single instruction, but that's not the case with Allen Bradley. In Allen Bradley, if you want to have an up down counter, you need to use an up counter plus a down counter. Together, you should be able to implement an up-down counter. And in some PLC, we do have high-speed counter, and Allen Bradley is one of them. So we do have high-speed counter in Allen Bradley's PLC, and don't forget, similar to timer, the counters are output instruction, which is very important to remember. Let's take a look at counter instruction in PLC 5 and SLC 500. You know that PLC 5 and SLC 500 are two different type of rack-based PLCs. So our focus right now is on rack-based PLCs counter. We want to see what are different parameters, what are different bits that we need to know about when we are working with counters. It is clear that counter instructions are software instruction, so you can have a large number of counters in your program, and the number of counters you can use in your program is only limited by PLC memory. Here you can see 3 different parameters that you can set for your counter. The first one is the counter number. So the first parameter is going to be your counter number. The second one is going to be your preset value. And the third one is your accumulator value. The first 2 are mandatory, so you have to describe your counter number and you have to tell your counter what is going to be your preset value. But for the accumulator value, you have the option to set your accumulator value on a specific number, or if you don't set it, then the program will consider 0 as the default value for your accumulator. Let's focus on counter number. The syntax that you have to use is in this form. So first, you need to describe file type identifier letter, which is C. Then you have to use your file number, which is 5. Then you have to use colon. And after colon, you're going to have your counter number. So for example, it can be 0, it can be 1, 2. So whatever you're using tells you what number is your counter number. So here, what we have here is our counter file. And you can see that it's referring to different number of counters. So for example, if this is the counter you're working with, the information of this counter will be saved in this block of memory in counter file. So this is C5:4, which is referring to this counter, and the preset value and accumulator value will be shown here as well. These are the bits that we're going to talk about them later. Now you can enter those parameters, your preset value, and if you're interested, your accumulator value, either in your instruction or in your counter file. It doesn't matter. The only thing you should be careful is using the correct syntax for your counter number, so it lets the processor know which block of memory you are using to save your counter information. The other 2 parameters that we need to talk about are preset and accumulator value. Both of them, both preset value and your accumulator value, they use one word to be described. So you have one word for your preset value, and then you have another word for your accumulator value. One word means 16 bits, and if you want to describe a positive and negative value with 16 bits, the maximum you can describe is going to be 2 to the power of 15. So it means that the range of values you can use for your preset or accumulator value is going to be something from minus 32,768 up to 32,767. The reason that this one is one value smaller than the other one is that 0 also is considered as a positive number. Here you can see the range of value that you can use for your preset and your accumulator value. You can set your accumulator value at any number, but the accumulator is going to be 0 whenever the counter is reset. So if you reset your counter, your accumulator value goes back to 0 no matter where it was previously.